Okay, so my slides, and this is my school, Nanyang Technological University. And over here, I'm working with digital humanities researchers to introduce to them knowledge graph technologies as well as Neo4j technologies. Um, but my talk today is focused on the visualization, graph visualization. So when we have a knowledge graph, we have to present it to end users. And I think the most natural way to present it is to render a graph visualization. I'm going to introduce to you Cytoscape. I looked around and explored various visualization libraries, and I found Cytoscape to be at the right productivity level, and it has been able to meet our needs. Now, to motivate this talk, let me introduce to you three of the knowledge graph applications that I've developed to show you what Cytoscape visualization can do. The first one is the Zubir Said personal archive. Zubir Said was the composer of the Singapore national anthem, and I'm using a knowledge graph visualization interface as an interface to a digital heritage collection or a personal archive collection. So I'm using the visualization not just for visualizing, but to to as an interface to the database. So the knowledge graph is used to link digital resources that are available in the collection and in the database, show relationships between the digital resources as well as to concepts, show any structural patterns in the network, and this is to support end users. So all the applications I'm showing you today are accessible on the web to public users. So this is to support mind mapping, browsing, learning, and I'm hopeful that it will help users to synthesize a coherent understanding or narrative about particular topics. So let me go on to the demo to show you these three um, applications. So this is the Zubir site website. And you can see here zubirsite.sg. So if you go there, you'll get to this page. I'm going to select a song. And the obvious one is Majula Singapura. And that is the national anthem of Singapore. So you can see that this visualization is showing you various resources that are available in this collection and how they are linked together. So these are mainly, for this graph, mainly different versions of the song, including the version that is longer than the national anthem, because when it was made into a national anthem, it was edited and a small section of it was removed. So you can interact with this graph, and if you click on these nodes, you can see the node properties displayed in this pop-up box. So, and you can click on this, and this will give you access to the resources in the collection. You can also interact with this graph by double-clicking on it, and that will retrieve neighboring nodes. That means resources that are linked to the node. So let's say if I double-click on this person, Fun Yu Tian, okay, you can see that there are some resources that are linked to this person. He was a composer, and he arranged another song that was written by Zubir Said. So if I double click on this again, okay, you can see that neighboring or related resources are displayed here. Other ways of interacting with this is, of course, filter. Quite often, the knowledge graph that is retrieved may be too big to display well on this canvas. So if you move your mouse over, this sliding window has a filter, and you can decide which node types to remove from the graph. The filter also applies to the links, so I could focus on what links I want to display on the graph. So let's say these. Okay. Of course, you may want to try different visualizations because that will help you to make sense of the graph. So a tree visualization, a tree graph, concentric circles, force-directed graph. So these layout algorithms are available from the Cytoscape website, and various third-party coders, researchers have developed layout algorithms. The ones I list here are my favorite. This is a force-directed layout, and if you click on it, multiple layouts are shown. But the default algorithm is this one that I use that animates the rendering, and it shows the incremental improvement. And you can see that I can interact with it to help it, to disentangle or unentangle the graph. Okay, let me go on to show you other networks that is available here. So the buttons here would retrieve subgraphs from the Neo4j database. So I click on this, you see a network of photographs and people, and so this is also in the archive collection. And then letters, okay, and you can see how the letters are related to each other, who are the senders, the recipients, and um, whether they're in response to another letter. Okay, let me move on now to another application that I'm currently developing. And this is the Chinese traditional medicine database. But we are expanding it with collaborators in the region to Southeast Asian traditional and herbal medicine, and to Asian traditional medicine. So we are very excited about this graph. Right now, there are 100,000 nodes and 50,000 herbs that's listed here. So you can see this visualization again. This is the main um, herb that's displayed, the main record. And these are related drugs or related names, alternative names, and scientific names. So for example, for this scientific name, if I double click on it, it will show other drugs with the same or other herbs with the same scientific name. This interface, oh yes, something I would like to point out is there is an improvement or development in this graph, and that you can see that nodes that are similar are grouped together. So this is a feature of Cytoscape where you can define parent nodes that groups together more the individual nodes. So I think this helps to the user to make sense of the visualization. You'll see here that there are tabs here as well. And these tabs are actually, they reflect the graph. Okay, so this is like a text version of the graph. So for a particular node like this, okay, you can see that there are alternative names, provenance, scientific names displayed here. Okay? So for example, if I click on this, focus on this in the main panel. Okay, so this is the provenance, meaning the ancient book where this drug was first reported. And you can see other drugs that are listed in this book. And if you click on author, who is the author, and if you focus on this at the main panel, you can see that the the graph visualization is showing, additional nodes as we interact with this interface. And this author apparently wrote 3 other medical books. Okay, one last application to show you, and this is to show you additional features of the Cytoscape visualization. The purpose of this project is to develop knowledge graphs that reflects the research results from research papers. So right now we are working on medical research papers as well as social science. So this is an example of social science research paper, and we are extracting cause effect information from this research paper. So from this general statement, okay, let's see what kind of cause effect information is found. So we see here economic deprivation in childhood influences mental health when you are an adult. And let's look at other statements. The summary of the literature review. Okay, early experiences has links with adult health problems, and then the research gap and research objectives. So you can see that we are trying to trace the argument through this social science paper from the the main statements, the argument statements or rhetorical statements, to see how this causal information or causal knowledge is developed throughout the paper. Okay, now if I right click on this, you can see that the concepts here are linked to a taxonomy. Okay? So you can, by doing this, you can see how the different statements, the concepts in the different statements are linked together in the taxonomy. Okay, one last one. Okay, another way of visualizing this is to just have one frame and then add all the different concepts to this frame. So you can see that the research result has quite a lot of information about the causal relation. Abuse in childhood is consequential to heavy drinking, and there are mediator variables here. And now when I click on other statements, it tells me what additional information is contributed by these statements. So this research method statement has target population, data source, and so on. And then if I click on it some more, okay. So you can see it adds up. And then if I click on each concept, it links to the taxonomy so that I can see how the concepts are related. Okay, so I've shown you what I can do with Cytoscape. What is new in this visualization is that I've programmed the actual placement of the nodes. So you can see that these nodes here are placed relative to cause. Okay? So they are arranged this way. And I have to also figure out what nodes are already displayed. That means the locations are already used so that I can display the next node next to it, sideways. So this shows you that Cytoscape you can both use algorithms to plot, to render the visualization, but at the same time, you can also program the placement of individual nodes. Okay, now let's go on now to the technical details. So yes, I've shown you the Asian traditional and herbal medicine database, and then scientific knowledge graphs. Okay, I've just shown you the social science, how we are trying to visualize social science research results. Okay. This is the architecture of the web application. This is the normal, usual architecture. Here we have the Neo4j graph database and query results or graph query results from the database are sent to the user's browser to display on the browser. And there is this middle layer, an API that is the intermediary between the database and the user. Okay. So let's now focus on the user. Okay, so the user is displaying the web page that you saw just now on the browser. And that web page has JavaScript running in the background, and then the Cytoscape JavaScript library to render the visualization. This is the Cytoscape page. Okay, so everything is here. So this is JS Cytoscape.org. The whole manual is just on this page. The first thing to do is to visualize using Cytoscape is to define the style sheet. So you can see here that style sheet looks quite similar to a cascading style sheet. So the very first part of the style sheet, I've defined how to display nodes. So we have node, okay? And then I indicate which property to display as the node label, and whether the label goes into multiple lines, which I do because I use quite long labels because some of the labels are titles of books. And then I specify the maximum width, the shape of the node. And this is over here on the right is the style sheet for the edges or the links. And what is new here are the arrowheads, what kind of arrowheads, what color, and whether the arrowhead is filled. And of course, you would want to have different styles for different types of nodes. So we have I've shown here an example of style sheet for musical work. So I display using an octagon. Okay. But now, I have improved on the interface. So I put on an image. So I look for suitable images from the iStock library, and I got a license to use this image. And I think it was quite successful. I think I'm pleased with what I got from iStock website. Okay, now let's see what happens if the user submits a query, like maybe by pressing a button or double clicking on a node to the um, database. So the user will issue a fetch command to the API, and the API is the one that will select the query to send to the Neo4j database. For the API, I'm using a Node.js environment and implemented on a Google App Engine. Okay? So let's see what happens. What kind of coding I need to effect this. So starting with JavaScript, sending a fetch command to the web API. Okay? So the interface fetches data from the API. So there's a fetch command and then the API string. The API string is just the URL of my API. So I'm using this chrisku.net as the URL of my API. And you can see here there's ZS or ZS, which is Zubir Said. So this is called the router, or you can think of it as the endpoint. And then there are a set of parameters. So for this particular router, I have two parameters, the query number. So I store all the Neo4j queries on the API, not on the JavaScript on the user's browser, but in the API, and then various parameters. So in this case, in this example, there are no parameters. I just have an underscore. So when this is sent to the API, then we can see what happens. In fact, if you click on this, you will see the API working. So let me show you the browser. Okay, so you can see here, chrisku.net, ZS3, and then underscore. And so this is the result that came up. So this is the graph that is retrieved from the Neo4j database via the API. And you can see that the data is in JSON format, if you're familiar with this. And when I code this, I have to figure out, what data is in this JSON format. I think when you look at this, you can kind of figure out what is the relevant data. You can see here that there's labels, musical work. Yeah, so the label is the node label, or in ontology, it could be called the class. So this is the class name, or in Neo4j, it's called the node label. And then these are the properties that are stored in the node. You can see that I have my own label. This is a text label. Okay, and then various other information. Something to note here is the identity number 1678. This is the ID number of the node in Neo4j. It is generated by Neo4j. It's not my own number. So it's an internal node ID number that Neo4j generates for each node. I highlight this because I make use of this same number in the Cytoscape visualization. So in Cytoscape, I also have to create nodes to display, and each Cytoscape node will also have an ID number, and I use the same ID number in Cytoscape. Let me go back to my slides to tell you more about this. So this is what you saw just now, musical work, and then 1678. Notice that all this relevant information in this attribute called fields underscore. So underscore fields, there's identity, which is the node ID from Neo4j, and then labels would be the class name, okay, or in Neo4j is called the node label. Okay. And I'm going to show you a more complicated example. And this is where the retrieve graph is not just one node. Okay, previously we only retrieve single nodes without relations, but this one has a node followed by a relation linking to a second node, with another relation linking to a third node. So something like this. Okay, so it's more complicated. The JSON data format reflects this sequence. So you can see here that this is information for node 1, and then the relation, and then node 2, and then another relation off the screen, and then node 3. Okay? And notice that there is still this ID number 402 for node 1, and for node 2, it's 378. Yeah. And the relation indicates the link between node 1 and node 2 by referring to this ID number. So we have 402 and 378. And here we see here, start as 402 and end is 378. Yeah, so you can see that you can make out, what is happening in this JSON data. Yeah. I mean, if this is too elementary for you, I do apologize, but I'm trying to make my presentation more accessible to digital humanities researchers, and I hope there are some in the audience. Okay, then what next? Then I use the Cytoscape command to create a Cytoscape object. Okay, Cytoscape. And this object will be associated with this HTML element with the hashtag CY. Okay? So this is a div tag, the display canvas that you saw earlier. And then to add a node, what I do is I have to map the data from here to Cytoscape. So I say add a node, add data, that means a node. And then the ID, the Cytoscape ID is the same ID as in Neo4j identity low. And then I then add in the other attributes like node labels. And notice that here, all these information are from the fields property. So fields here, okay? Fields. Okay? So all this information is added to the node. Okay, then after adding all this to Cytoscape, I have to render it. So I use these layout algorithms. I indicated earlier that my favorite algorithm was this force caller. I do this, I execute it here. But I found that it's useful to apply force cause first, and after that to apply force caller. The reason is because force caller will take some time to incrementally improve the graph. And if the graph is big, it is quite overwhelming for the user and lots of things happening on the screen. So that's why I found it works better to apply force cause here for an initial layout, and then force caller for additional improvements. Then, okay, so how do you code interactions with the graph? Okay, so this is the code for double clicking on a node. And you can see that it's pretty easy. So I specify, I said okay, this is a Cytoscape object on double tap. Okay, so double click and double tap are combined together so that you can use it on iPad and touch surfaces. And then the node that is tapped on will result in an event object, which will include the node ID. Okay? So then I use the node, I select the node, and then I lock the node, and then I send retrieve a command using the node ID. Okay? So I'm using this ID too is not the Neo4j node ID. This is my own ID, which I use then as a query to Neo4j to retrieve neighboring or related nodes. Yeah. So I indicate the query, the Neo4j query that I want to use. And I call this query 0. And all my applications are query 0 because query 0 is always used because all it does is it just retrieves neighboring nodes. So if you're familiar with a Neo4j, this is a Cypher query where you match a particular node ID and you're retrieving the related nodes, the relation and the linked entity. And this will then add this new information to the graph. Okay, so retrieve, and then I indicate the node that was tapped, was double clicked on, and then the ID2, my own ID2, and that goes into the submitted as a parameter to this query 0. yeah, that will retrieve the related nodes. Okay, so that's it for my talk. I hope that this is illuminating to you. And if you're a digital humanities researcher, I hope you see value in applying graph technology to your data.